Okay guys, this is section 6.2. We're finding the area under a normal distribution. Normally if we were in class and it was a block day, we would have covered 6.1 and 6.2 in the same day. So it flows very much along with section 6.1. Last time I told you that we were working with a normal distribution. Normal distributions are for continuous data. Continuous data. Think about the lengths, heights, weights, things like that, okay? Binomial was in the last chapter, and that's if there was a success and a failure. This is continuous. So what does that mean for us? That means I can't go and find each and every individual probability and put them in a table. So today we're going to look at why we're doing the area under the curve. So I have my normal distribution curve. It's the area that we are finding. So if there's anything you grab out of this, the area under the curve is the probability of the event. Okay? They have gone and found all of the probabilities that are possible using that nasty little formula that I showed you last time. Remember this guy? Ooh. Actually, they didn't go find that one. They used calculus. It's much easier. But anyway, they went and used the formula or used calculus and found all of the probabilities. We just got to learn how to do it. So I brought an example along so we can talk about him. The average height of an American man is 70 inches. The standard deviation is 4 inches. We want the probability of a random man being over 74 inches tall. So let's think about how that looks on our normal distribution. His average height is 70 inches, and the standard deviation is 4 inches. So here's one standard deviation and two, and we could go the other way too if we wanted to. Okay? We want to find the probability of him being over 74 inches tall. The probability that it's over 74 inches. So we go over here to 74, and everything to the right is a height that is over 74 inches. See, he could be 74.1 or 74.25 inches or something like that, right? Or 76.37 inches, whatever. But it's a continuous set of data, so I have to go find the area because I want all the probabilities that are over 74 inches. Okay? And so we use calculus to find areas under a curve. That's what that's for. And so they have normalized this, standardized it, and put it on a table. So that's going to help us out. So the first thing we want to do is to figure out how to look at this information, and then we'll look at the table so you can see how that pans out for us. Alright, just a couple of little notation things, okay? We don't find the probability that it equals something. So remember our notation. This is the height of an American man. This is 74. That doesn't exist because this is continuous data. So where do we cut off, right? Okay, so instead we would find the probability that it is less than 74 or greater than 74. And here's where math breaks down and we just, makes us cringe. Ready? Less than or equal to is the same thing as less than. Greater than or equal to is the same thing as greater than. So when we say that we want to find the probability it's more than 74 inches, it doesn't matter if it's 74 and up or just above 74. It's going to have the same area under the curve. It's because we're finding the area, okay? Cringe. Now, here's the problem. We don't look up x's because it would be different for every set of data. Every set of data that we have has a different mean and standard deviation. So what we do is we standardize it, okay? We go and find z. That's why it's called the standard score, z. Remember that z is x minus mu over sigma. x minus mu over sigma. There you go. All right, so we're going to find z, and we change him to a z-score, and then we will find the probability for this value, okay? Z means the standard deviation away from the mean. That 74 inches is a certain standard deviation from the mean. In this case, where'd he go? On here. In this case, it happened to be exactly 1 standard deviation. So in this case, z equals 1. So we're finding the probability that it's more than 1 standard deviation away. So instead of looking at it as 74 inches, we're looking at it as more than 1 standard deviation. Okay? So that's what we're doing. We're changing it from an x value to a z value. So to find an area, 2 things you're going to have to know about. First of all, we're going to convert the x's to z's, and then we're going to grab our table, and the table gives the area under the curve to the left. Did you notice it was in all caps, boldface, underlined, and italicized, and I just circled it like a crazy person? To the left, okay? The area to the left is in the table. Mrs. Noble, you keep saying tables like I know what you're talking about. Yes, I do, don't I? You know what? I usually use this little picture of a random table, but with the power of the interwebs, we can use the for real tables. Remember this orange sheet? You need this thing, okay? I hope that you have it with you at home. If you do not, it is also in the textbook. It's in the very back, right before the odd answers. There's a bunch of appendices. This one is the first one. It's called Standard Normal Distribution. So if you don't have this, hit pause, go grab your book, and go look for it in the book, okay? It's at the back of the book, right before the odds. All right, a couple things to note here. Remember I said it was the area to the left, so they drew you a little picture up here. Mine was not darkened in very well, so I shaded it in a little harder so you could see it better. If yours is not shaded in very well from the copy machine, just shade it in a little bit better, okay? Notice that they give you your z, x minus mu over sigma there, so you don't have to memorize anything. We're going to just know how to use it. I want to show you some things on this table. These are the z-scores on the outside. Z's are on the outside. These are the area under the curve to the left. Area to the left, this guy, okay? So let's say we're out here at negative 3.49, negative 3.49 standard deviations from the mean. That means way down there. Remember that 3 standard deviations contained like 99.7% of the data? So it's not very much down here. It's a tiny little piece. In fact, the area down there would be 0.0002. Not very much area. Okay. Let's go look up like negative 1.55, just to use the table. So here's negative 1.55 is 0.0606. Did you find it? 0.0606 is the area to the left of negative 1.55. Okay. Notice how far this table goes on this side. It goes to negative 0.0. It's 0.5. Why? Because at 0, it's cutting it in half. So, yeah, half of it's here and half of it's on the other side. Voila. Alright, so this only gives you this left-hand side from negative infinity to 0. Okay? Flip the page. On the back side is the positive direction. Okay? So any z-score that is above 0, positive z-scores, are going to be on this side. But remember, it's the area to the left. See how it's shaded in? If yours isn't shaded very well, you could shade it in a little darker. I don't know how the copy machine looked for you. Okay, so this is from negative infinity up to a positive z. Watch this. 0.0 again is 0.5. Woo woo. Look at 1.55, positive 1.55. Go find it. There. 0.9394, is that what you found? All right, 0.9394 is the area from 1.55 on down to the left. Okay, it's most of our data, right? Okay, because the area under the curve is 1. Notice how far up it goes. 3.49 is 0.9998. Remember on the other side, negative 3.49 was 0.0002. What? Guys, the area under the curve is 1. So, yes, they're going to match up. So, we're going to learn how to use that in the next video. I'm going to do the examples on the next one so that you can see those separately and hit pause and rewind and whatever you need to do, okay? So, go to the next one. I'll show you a bunch of examples of how we're going to use this table and find probabilities.